All right, good afternoon, my lovely QR students. You all should have by now picked up a bell word and should have answered both sides of it. So what I want you to do is I want you to start checking your answers. So I'm going to display those and I'm going to explain them as I go, okay? All right, so the first question that you're asked to do is describe the shape of each histogram using words like symmetric, left skewed, right skewed, bimodal, and uniform, okay? So when we look at this first one, this one is symmetrical because as you can see, it is very close to like a bell-shaped curve, okay? On the second one, this one is right skewed because if you look here, the tail is facing to the right. So remember, I kind of use the analogy of think of a kitty cat and it's standing and its tail, whichever direction its tail is pointing, is how we describe the skewed. The next one would be left skewed because again, if you look here, you could see that the tail is facing to the left. So again, think about that kitty cat, meow meow. All right, the next one would also be left-tailed or left skewed because again, we see kind of this pattern here, tail on the left. We wouldn't call this bimodal because these bars over here, they aren't quite the same height as the ones over here. So we're not going to call this bimodal. And the last one is roughly uniform. Yeah, I know there's a couple of peaks that are a little higher, but generally it kind of makes a rectangular shape. Okay? All right, so now let's talk more about a histogram. So you'll be asked to or on the quiz today, you're going to be asked to look at a histogram and be able to figure out the shape, which is what we were just talking about a moment ago. In this case, it is left skewed because, again, think of the kitty cat and the tail pointing on the left. To find the center of the data, what we're going to do is we are going to take our frequencies, so the 10, the 20, the 60, the 90, and the 30. We're going to add those numbers up and divide it by 2. What that does is it gives me like what is the halfway value. And when I add those values up and divide by 2, I get 105. So what we're looking for is the 105th value. All right, so if I take 10 plus 20, that's 30. 30 plus 60 more, that's 90. I need to get to 105, so I need to be in this part of the histogram, which is between 60 and 80. All right, so that's where the center of our data is. Now, please note that it is not always going to be the tallest column within this data set. That's just where it fell this time, but just know that that is not always going to be the case. All right, so after we do that, then it is going to ask you to figure out what percentage of students had a score between 20 and 60. So the way we're going to do this is we are going to look between 20 and 60. So we're looking at this section here. We add 20 plus 60. This is just a coincidence that those numbers are the same. But the 60 plus the 20, I add those together. That gives me 80 out of the 210 that we had total for all of our frequencies. So 80 out of 210 is about 38%. And then on this question here with the given histogram, why is it not possible to see the original data values? Well, the reason we can't see the original data values is because the data is grouped into intervals, right? So age intervals, or not in this case. In this case, it's grade intervals. So the original grade scores are not visible, right? So I don't know, I know that there are 30 people in this column that got between an 80 and a 100, but I don't know what the individual 30 students' scores were from this histogram. All right, so that's one of the downsides of a histogram. You don't necessarily get back the original data, okay? But when you're doing a histogram, you're not necessarily worrying about individual student data values. You're kind of looking for more general trends of a class or a group of data. So that's why that you don't necessarily need that. Okay, so then the next thing that you all were asked to do is to find the 5-number summary for the data listed below. All right, so what I did first was I counted how many data values I had. And in this case, I had 12 data values. So to do this, you're going to want to actually find the median first. And since we had 12 data values, that means that the middle is going to have 2 numbers here, so 12 and 13. When you have 2 numbers in the middle, you add the 2 numbers up and divide by 2. And so in this case, I take 12 plus 13 divided by 2. That gave me 25 divided by 2. So my median is 12.5. That's halfway between 12 and 13. So that's how we're going to get our median, okay? What the median does is it splits our data into 2 equal halves, okay? So since our median was actually between 12 and 13, this black line separates our data into the lower half and the upper half, okay? So now we want to find the Q1, which is the lower quartile, and that is just simply going to be the median of the lower half of the data. So in the lower half of the data, I have 1, 2, 3, 4, 5, 6 data values. So again, I'm going to have 2 numbers in the middle, 8 and 9. So I'm going to add those together and divide by 2, and that gives me 8.5. Okay? So that's my Q1. To do the Q3, which is the upper quartile, we're going to just do the same thing we did for the lower quartile, but we're going to look at the upper half of the data, okay? And again, there are 6 data values in the upper half, so there's going to be, you know what? I did not calculate this correctly when I did this, so I'm glad you're watching this video right now. I got the wrong upper quartile. Let's recalculate that, okay? So my values that are in the middle, I have 13, 14, 14, 16. These should have actually been the 2 numbers in the middle, which means that I would do 14 plus 16 divided by 2, which is 30 divided by 2. So actually our Q3 is 15. So my apologies on that. Okay, now that we see that that's the correct answer there, we can find our min and max. We could have done that at the very beginning if we wanted. So now we make a box and whisker plot. So my box and whisker plot I need to make an adjustment for because this upper quartile here, this is wrong now. That should have been here. So this is what it really should look like. Okay, everything else looked good. Just mess that up. So when you're checking your answer here, look at the red graph, okay? I am so sorry about that. Okay. All right, so that is the actual box and whisker plot. So go ahead and make sure that you get that corrected. All right, and then you are going to be asked to use a box and whisker plot to answer some questions. So remember, one of the key features about a box and whisker plot is that each of these sections here represents 25% of the data, okay? So each of these 4 sections is going to be a quarter of the data. All right, so if I want to know what percentage of data falls between 4 and 10, well, that is going to be from here to here. So that's this group and this group, so that's 50%. Okay. If I look at the next one is greater than 16. So here's my 16. So we're looking at this section of the data. This is just 25% of the data. To find the interquartile range, you're going to take your Q3, which is your 16 here, and subtract your Q1, which is going to be this 8. So 16 minus 8 is 8. And then to find your outliers, you're going to use the formula for low outliers. You do your lower quartile, so Q1 minus 1.5 times the IQR. So in this case, it's 8 minus 1.5 times 8. If I multiply 1.5 times 8, I get 12, and so 8 minus 12 is negative 4. All right. So if you had a value of negative 4 or lower, that would be a lower outlier. In this case, we didn't have any. On the upper end, we're going to take our Q3 and add 1.5 times the IQR. So in this case, that would be 16 plus 1.5 times 8. That gives us 16 plus 12, which is 28. Since we did have a data value that was exactly at 28, 28 actually ends up being an outlier. Okay. All right. If you want more practice here, we can go through these questions here just to make sure that you know how to do them. If you're like, no, Mr. Bear, I already understand this, you can go ahead and stop the video now and then tell your guest teacher that you are ready for the quiz. All right, so if you're still with me, let's go ahead and try this out. So on this one, we're going to describe the shape. So if I do this, I notice that I have a tail facing to the right. So this is right skewed. The center, we're going to add these numbers up. All right, so we're going to do, I'm not going to write it all out, but I'm going to take my calculator and I'm going to add 10 plus 45, plus 65, plus 33, plus 45, plus 20, plus 12, plus 10, plus 1. I get 241 when I add all that up. I need to divide that by 2, so I get 120.5, which will round up to 121. All right, now that means we need to find where our 121st data value is. So 10 plus 45, that's 55. 55 plus 65 gives me 120. All right, so notice here this time I'm still not at my center, so I have to go to the next one. So my center is between 41 and 50, okay? Remember earlier I said that your center does not have to be the tallest bar of the histogram. All right, and then it says, can we determine the individual data values? The answer to that is no. The values are grouped by intervals, or grouped in intervals. And what that means is, like, let's say in this first bar, I know that I had 10 data values between 11 and 20, but I do not know how many of them were each score. I don't know what each of those scores were. All right, here's another one, 5-number summary. That means you just tell me the minimum value, which is 60. My Q1, which is here, that's going to be 70. Median is at 80. Q3 is here at 85. Maximum is here at 90. To get the IQR, you're going to take Q3 minus Q1, so 85 minus 70, which is 15. Okay. To get your outlier bounds, you're going to do for the low ones, you're going to take Q1, which is 70, minus 1.5 times 15. So I'm going to use my calculator, and I'm going to do 70 minus 1.5 times 15. We're going to get 47.5. So any score that is 47.5 or lower will be considered an outlier. For the high outliers, we're going to take our Q3, which is 85, and we're going to add 1.5 times our IQR. So 85 plus 1.5 times 15 gives me 107.5. All right, and in this case, I can see that I don't have any outliers of any kind because none of my data values are lower than 47.5, and none of my data values are higher than 107.5. Okay. Last one here, this one, we've got a set of data. The data is put in order, so that makes it nice. I don't have to put them in order first. To figure out the outliers, we're going to first figure out our medians. So let's see how many data values we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so that means I'm going to have 6 values in the lower half and 6 values in the upper half. Our median is the middle of 16 and 18. So 16 plus 18 divided by 2. 17 is our median, okay? For the Q1, we look at the lower half of the data and we find our median there. So it's going to be between the third and fourth data values. 8 plus 9 divided by 2 is going to be 8.5. For our upper quartile, we're going to look at the middle two values in the upper half. 33 plus 40 divided by 2, that's going to be 73 divided by 2. Let's go ahead and figure out what that is. 73 divided by 2 is 36.5. Your interquartile range is just going to be your 36.5 minus 8.5. And that gives me 28. For your low boundary, you're going to take your Q1, so 8.5, and you're going to do minus 1.5 times the IQR. So if I do 8.5 minus 1.5 times 28, I get negative 33.5 or lower. So there are definitely no outliers on the low end. Now let's see the high end. Q3 was 36.5 and plus 1.5 times 28. So I'm going to put this into my calculator. And that gives me 78.5 or higher. So in this case, I don't have any high outliers either. So no outliers. All right, at this point, you should now be ready to take your quiz. Now, because I'm not here, I am allowing you all to use your spell work on this, but hopefully you are feeling confident. So go ahead at this point, close this video out, and the guest teacher should, at this point, give you your quiz. When you're done with your quiz, just turn it in and then make sure all of your Unit 5 IPs are completed.